important clues about the way the world looked like millions of years ago are locked away in layers of rock. Impressions of past plants, leaves, animals, insects, or even poo can be discovered in rock. But how did they get there? And how do we find them? Let's find out together in this episode, all about fossils. A fossil is any preserved body structure or impression of an organism that lived in the distant past. This includes things like a preserved footprint, a leg bone, preserved feather impressions, or entire skeletons. Fossils help scientists called paleontologists learn about what these past organisms ate and what ate them, and all about the environment in which they lived. There are many ways in which fossils form, but it is not always easy to become a fossil. Where the organism lives and what type of materials make up its body structure are strong factors that can influence the fate of a potential fossil. Fossils can be preserved in volcanic ash, ice, tar, desert sandstone, river sediment, or remains of hardened tree sap. If conditions are right, hard structures like exoskeletons, bones, or wood can go through a process called permineralization to become a fossil. This process can happen in several ways, resulting in different types of fossils. But the basic method can be summarized in these 3 steps. The first step in becoming a fossil is death. I know, dramatic. The plant or animal first has to die either through a disaster or predation. But not everything that dies becomes a fossil. If that were the case, we would just have mounds of dead organisms everywhere, and no one wants that. So thankfully, some of the dead organisms break down and are recycled back into the environment by our little decomposer friends, or eaten by scavengers, like this cute little vulture buddy. So step 1, death. The second necessary step is for the organism to be covered in sediment. This can happen quickly, like in a land or mudslide, but sometimes it takes more time, like the organism sinking to the bottom of a lake. It is important to note that there are cases where the event that causes the organism's death is this rapid covering of soil or mud. This covering is key to preventing the decomposition or scavenging of the organism's remains. Some organisms are more likely to become fossils than others because of what paleontologists call the preservation bias. This means that not all organisms are going to be preserved. There are certain conditions, such as aquatic areas or low oxygen environments, or the speed of burial, that allow for better preservation than others. Animals with hard parts, such as bone, are more likely to be preserved than animals that have soft bodies made of things like cartilage. Aquatic animals are more likely to be preserved than terrestrial animals because water ecosystems have a greater preservation potential than land ecosystems. I'm here at the beach looking for fossilized shark teeth. Shark teeth are the most common fossil discovered, but why? First, shark teeth, like most teeth, are made of dentin, a hard calcified tissue that does not easily decompose. Dentin is harder and denser than bone. Secondly, to maintain that classy toothy smile, shark teeth are designed to regularly fall out and be replaced. On average, a shark has 40 or 50 teeth in its front row of teeth, or dentition, and that row is replaced every few weeks. Now multiply that over millions of generations of sharks over tens of millions of years, and bam! Shark teeth are awarded the most common type of fossil. The third step in becoming a fossil requires time. Lots and lots of time. Once buried, the soft parts of the animal usually rot away, leaving the tough bones. Bones are full of tiny pores, open spaces kind of like this sponge. Minerals in groundwater can fill pore spaces in bone, like this liquid wax fills spaces in the sponge. When we cut into the sponge after the wax has hardened, you can see how all the empty space is filled. Those groundwater minerals then replace the organic material of the animal and turn it to stone. This is called permineralization and replacement. When observing a fossil, you may think that you're looking at the animal's actual bones, but really, you're looking at a rock in the exact shape and size of the animal's original bones. There are several other ways in which animals can be preserved, including molds, casts, and the most impressive true form fossils. If you're still here liking this video, let us know, and hit that subscribe button so you never miss an episode. Let's take a quick look at different types of fossils. Sometimes an animal or a plant will just leave impressions behind. These are called a mold fossil. Sometimes these impressions are all that's left of these organisms, like these shell impressions in this limestone creek bed. Mold fossils are kind of like pressing a leaf or shell into soft clay or mud. You can see the shape of the leaf or shell. If the clay or mud hardened into rock, it would become a mold fossil, just like these. Then, not all fossils are even of an animal's actual body. Other evidence left behind can be things like nests with eggs, or even dinosaur footprints, like these, found in Dinosaur Valley State Park here in Texas. During the Cretaceous age, dinosaurs left tracks in the soft mud of a shallow sea that covered central Texas 113 million years ago. Dirt and sediment covered the dried prints. Through thousands of years of erosion, this river slowly revealed two types of tracks: the three-toed tracks of theropods and the saucer-shaped tracks of sauropods. The theropod prints probably belonged to the carnivorous Acrocanthosaurus. Acrocanthosaurus ran on two legs as it pursued its prey, reaching up to 38 feet long. It left tracks ranging from 12 to 24 inches long and 9 to 17 inches wide. Sauropods were large, plant-eating dinosaurs. Their pillar-like legs and large feet left distinct prints in the mud. These prints were the first distinct sauropod tracks found in the world. Scientists have determined that the sauropod tracks belong to Sauroposeidon. The 50-ton sauropod stood 92 to 112 feet long, 20 feet high, and 6 feet wide at its shoulder. Its almost 40-foot-long giraffe-like neck was longer than its tail. Sometimes that imprint, or mold, left by a plant or animal is filled with minerals that then harden into rock. When this happens, it's called a cast fossil. I have set the mold we made from earlier so that it is now rock solid, like a fossil. If I press new clay into our mold and remove it, we now have a cast. Then there is a true form fossil. These are not made of stone like most fossils. This is the actual preserved body of the animal. This happens when the animal gets stuck in sticky sap that turns to amber, is frozen in ice, or trapped in a tar pit, which all sounds terrible. During any of these events, the animal's body is not exposed to oxygen or microbes, so it doesn't decay and is preserved. Go be a detective today and see if you can find clues to the past trapped in rocks. And if you want to learn more science, you can check out this video next. Cretaceous. During the Cretaceous Age,